So, ports, OpenBSD ports. Why do you want to do this? It's a question I ask myself every day. But in all honesty, in all truth, ports are both a really easy way to get involved with OpenBSD development. It's a really easy way to actually make your own life a lot easier, especially if you're using OpenBSD a lot. Because it forces you to, in essence, write down the steps it took to compile some piece of software that, at least in theory, you're going to use. And I know, from my vantage point, there are definitely ports that I have in the porch tree that, if I did not make a port of it, I definitely would not be able to retrace my steps and recompile it a second time. So it helps you. And also helps everybody, right? In theory, if you need some piece of software, somebody else also needs that piece of software. So putting in ports makes everybody's life easier. And yeah, so let's get started. So let's start first by just looking at what a package is, right? Because ports make packages, and when you install packages, that is the only thing you install. So when you type make install in the ports tree, it goes and builds the package and then installs the package. Right, and historically that has been different than FreeBSD, although that's no longer the case for FreeBSD anymore either. So let's go to a mirror site. I have this one. This is ftp4.usa.openbsd.org. This is the one that's run in New York City by Nicebug. So let's go to some random, whichever one is closest to you, mirror site, and go to the packages directory. I'm going to assume that everybody's using AMD64 because I am, and because for most people it's going to be the fastest machine that they have. Which, tip number one, you should develop your ports on the fastest machine that you have. Otherwise, you will spend a lot of time waiting for compiling to happen. So save yourself the headache and the time, and get a decently fast machine and do your development work on that machine. All right, so let's pick, let's pick something small. I guess Nano's small, right? And most people are at least familiar with Nano. So let's download Nano, the actual package. Don't package at it. Actually, use FTP and download it. All right, great. So there's Nano. Let me just throw it in its own directory. All right, so let's actually extract a package and see what we get and see what's inside. All right, so what do we have? And let me clear this out. So what do we have here? We have a contents file, description file, and then what essentially looks like a file hierarchy, which it is. It's a hierarchy within user local, or whatever your local base happens to be. For the vast majority of us, that is user local. And if you install packages, that's where it goes. User local, whatever. So what's important to us here is this content file and this description file. And if we just, for example, ls the bin directory, we have the actual executables. If you ls man, you'll get the man pages, and so on and so forth. But let's look at what we have in this contents folder. Boy, that's a lot of stuff. There we go. So contents kind of looks like what we'll see as a plist. And in fact, it is a plist. It is just the long form version of it. We don't see this entirely when we actually make the port. We kind of see a smaller, more condensed version. A smaller, more condensed version of the plist. But let's just look through this full plist and see what we have here. So plist starts with a comment. It's a comment. It has the OpenBSD CVS ID on it. We can safely ignore that. So name, what's the name of the package? This package name is Nano 2.9.8. Version number, you can actually ignore. If you're super interested in what version means in this case, the ports tree can be set to increment its version both on a per architecture basis and architectures, and it's actually the summation of those two numbers. What those numbers do would rebuild the entire ports tree. So let's say there's some reason that the entire ports tree has to be updated for whatever reason, or rebuilt for some reason. I can imagine this will probably happen when we move to like LLD or something. And I think it happened when we moved to Clang as our base compiler, but I could be misremembering that. Short version is you'll never actually have to worry about the version number. It'll be the same for all your packages throughout each individual architecture. They can vary between architectures, but within each architecture, it'll always be the same. So for AMD 64, at least for now, it'll always be version 3. The next is a comment, which gives us our package path, which you can think of as just the category that the port lives in, followed by the port name. CD-ROM yes, FTP yes means can we essentially distribute the package. If we can distribute on CD-ROM, which is more or less historical these days because we don't actually ship CDs anymore. And then FTP, if that's yes, you can just package add whatever it is. The architecture, AMD 64. And then from here on down is just all the different files that are in the Nano package. And there's a lot of them. And they all come with their own hash. They all come with their own size. So that's what that stuff is. So mostly what's important for us looking at the contents file is what's towards the top. And then let's take a look at that description file. Now this looks a lot like what we'll see as the package description, which it actually is the package description, just with the maintainer and the home page tacked onto it. It should look pretty familiar if you've ever run package info on a package. This is what you get. This is where it comes from. And then besides that, what's inside is simply all software itself. So that's essentially what a package is. It's the software itself, neatly put into a file hierarchy that can easily be extracted into user local, and some metadata that helps package add and package info and package delete kind of deal with it as it needs to. So I thought we would start by actually making a package of our own. And the one we're going to do is the GNU BC and DC calculators, because they're easy. Hopefully it's enough that we can all kind of wrap our heads around them. If people have questions, feel free to type them into Twitch chat, because otherwise I won't be able to see it. Although I guess people are pinging me on Mastodon as well. So the hardest part about making a port is actually finding a piece of software to port. Once you've done that, everything else kind of falls into place, right? Because I don't remember the exact number at this point, but it's something like 10,000 packages are in packages at the moment. I think that comes out to be like 8,500 ports, unique ports, which is a lot. So actually finding good software to port is an interesting challenge in and of itself. But we're going to use GNU BC because I know we don't have a port of that. So I actually did send a port of it to the ports mailing list a month or two back, but no one ever picked up on it. But that's okay. This is just to do things. So let's go actually to the website where the software lives. And that's really going to be your first step. Once you've identified a piece of software to port, the first thing you want to do is actually go see the software that you're dealing with, like actually go to the website. So here we are. This will somewhat look familiar to anyone who's been on a GNU.org webpage. This is BC. It's a calculator. You type math into your command line and it gives you math back. Obviously, we also have our own BC and DC in base, user bin BC and user bin DC, which is fine, but we're going to try this one out for today. So, downloading. That seems easy enough. So let's download it. Just to see what we get. Alright, so let's download this one, because this one I believe is the newest. BC 1.07.1.tar.gz. Oh, by the way, I should have started with this. In your ports directory, if you don't already have one, make a directory called mystuff. Mystuff is a special directory. Everything inside it gets treated as if it was in the ports tree proper. But if it's in mystuff, then you can kind of keep track of all the stuff that hasn't been committed. It's a really nice extra directory that we all kind of get for free. So do all your development work, especially for new ports, in this user ports mystuff. So for now, I'm just going to see what's inside the actual software. So let's okay. So looking at BC, it looks to me, just from my own experience, to be a fairly standard GNU configure and followed by make install setup. And you can tell that because we have these interesting .ac files, which stands for autoconf. You don't actually need autoconf for this port because the configure script's already been generated for us. But in general, when you're looking at software, you're looking for make files, you're looking for configure scripts, you're looking for something that says something like cmake lists.txt. You're looking for some sort of way to actually build the software. For today, because it's just the basics, and I mean we're just going to do the basics because that's enough material as it is. We're generally going to try to stick to just simple configure scripts and or make files, because those are the easiest ones to deal with. Okay, now that we have a rough idea of how we're going to build it, we can actually go and actually start to make the port itself. So let me just open up another tmux window. So we're in user ports mystuff. First thing we have to think about is what is the name of our port going to be and what category is it going to live in. So if we look at user ports itself, we have all these directories. These directories are what we call categories. Every port has to live in a category. Technically, you can have more than one category, and we'll explore that a little bit later. But you need to have one, and the make file has to match up with whatever category you choose to put it in. For BC, I think math is probably the right place to put it. It is a calculator. In theory, you could also put it into something like system utilities, because it is technically also a system utility. But I think math is the right place for us. And uBlock origin has crashed. Thank you. So let's actually make the math directory. And I don't know, for now, let's call it BC, because that's the name of the piece of software. So we want to make math BC, and then we want to actually enter math BC. So let's cd into math BC. Now, for all of us, there is a nice template file that we can use to start off with. And that template file lives in user, ports, infrastructure, templates, makefile.template. So if we just copy that over to our new BC directory, then we can get started. Every port has a makefile. In fact, let's even rename it to just makefile so we don't forget. The make file we can think of as kind of like the master switch, the thing that actually makes the package from the source. So let's take a look at this make file and see what we have inside. Of course, you can use whatever editor you want. I'm used to VI, so I will use VI. So at the top here, we have this nice RCSID. Keep it. Do not delete this line. You don't even have to change the line. You can just leave it. Replace question marks with appropriate values. Remove extraneous comments before committing. This one we'll do at the very end. Use port check. Port check is a nice little script written a couple years back, I think now. 2014, 2015, somewhere in that time period. That will kind of just double check the port for all the basics to make sure it looks correct. Doesn't necessarily mean it is correct. It doesn't mean there won't be changes that you need. But as far as kind of just the nuts and bolts of how things should be organized, making sure you don't have any extraneous spaces, making sure that things are formatted correctly, port check is really nice for that and can catch a lot of mistakes. The first thing we encounter is reasons why the port or package shouldn't be built. For the most part, you won't actually touch this. But in theory, let's say for some reason, BC was written entirely in AMD 64 assembly. It couldn't be built on any other architecture other than AMD 64. You could, in fact, uncomment only for arches and type AMD 64 here. And that would signal to users and to the bulk builders that if you tried to type make build on some other architecture, it would give you a nice little error message saying that you can only build this on AMD 64. Otherwise, can't build it. But we are not going to use this, and the majority of ports do not use this. So we can get rid of this line. Not for arches is the opposite of only for arches. So if the list of only for arches are build on this, don't build on everything else, not for arches, if we did it this way, would be don't build on AMD 64, build on everything else. Again, for the most part, you won't actually use this one because most things will build everywhere. So let's just get rid of it. Comes with. Now, this one I don't think has been used in quite a while. This would be the case if, like TMUX, something that was in ports and then became part of the base system. That's what this one would be for. And I don't imagine anything I've ever done will ever end up in the base system. It's probably a good bet that for most of us, that'll never happen. So we can also get rid of this one. Broken is if the port normally builds and should normally build, but there's something wrong with upstream or something wrong with something that it's temporarily no longer building. And for broken, don't just say what architecture it is, because that's not super helpful. Actually say why. So let's say GNU BC was broken, I don't know, let's make up a reason. Because Brian is bad at porting. That would be a good reason. So now if you tried to build the port, it would say this port is broken and actually print out because Brian is bad at porting. So if you ever have a reason to actually mark something as broken, which you almost never will, it's important to actually give the reason why. But this port is not broken, so we'll just delete it. And we'll delete this whole block as well, because we don't need any of it. For most ports, the first thing that you will actually write yourself is the comment. Comment is we can think of it as the short description. It is up to 60 characters, which is nicely printed out for us. So from this pipe to this pipe is 60 characters. Comments begin lowercase and do not put the article at the beginning. So if you write a or the, just delete the a or delete the. So what should we put for comment? Let's go back to the BC website and see if there's any kind of short, snappy description we could use. BC is an arbitrary precision numeric processing language. That looks good enough, at least for now. So let's type that in. Arbitrary precision numeric processing language. And there's no punctuation at the end. So that's under 60 characters. So I think we did it. Multi-packages we will save for a much farther workshop, much farther down the line. For now, let's just get rid of it. So next is what port or package will be created. So we have package name and dist name. Again, let's just get rid of this multi-packages thing for now. Most ports don't actually use multi-packages. That's something we'll save for kind of a more advanced workshop. So you'll notice here that dist name is by default not commented, and package name is. And that's because package name will simply be set to dist name unless you tell it to do something else. We might have to come back to revisit package name, but let's leave it commented out for now. The dist name is the actual name of the tarball that you downloaded without the extension. So if we go back, the tarball we downloaded was this one, bc-1.07.1.tar.gz. So we just want to write out the tarball name, essentially, without the extension. So that for us would be bc-1.07.1. And that's it. We'll leave package name for now. We won't delete it because we may find that we will need to use it, but let's just leave it commented out for now. This part here about GitHub, I think is slightly more confusing. At least it's more confusing for me, but GitHub itself is kind of confusing. We're not going to necessarily need this for today, but because GitHub is so common, let's talk about it at least for a little bit. Actually, let's pull up the project that we're all going to port when this is over, which is a small little thing that I wrote, a little delete. So here, releases, preferred, ignore GitHub variables, just use master sites and dist name. We'll get to master sites in a second. Archive, GitHub account and GitHub project, plus either GitHub tag name or GitHub commit. What it's actually telling you to do is, if the only place to get a piece of software is GitHub, then we're forced to use GitHub. There's going to be a release tab, or at least hopefully there is a release tab for anything that you want to actually download and use from GitHub. And it always brings you to the name of the software / releases, which is not the releases that is being talked about here, which again is confusing. What it's actually telling you is there's always going to be a list of assets with every tagged release that will have at a minimum these two source code links. And if you look at the bottom left corner, there's an archive there, an archive directory. Some people who are nice, who are helpful, also upload their own already ready to download and compile tarball. And that is the releases that's being talked about here. So what that part of the GitHub is trying to tell you, what this is all trying to tell you is, if the upstream has gone ahead and made their own release tarball, to use that. If they have, the only options are these two source code links, to ignore the source code links and instead use these GitHub variables. So in this case, username would be replaced by Ibarra, project would be replaced by Shuff, and tag name in this case would be replaced by Shuff-2.0. But because in this case, there is a tarball ready to go, we're just going to ignore them. And for BC anyway, It's not downloadable on GitHub, as we already know, because we downloaded it. But as you kind of look through GitHub projects, because there's a ton of things that are on GitHub, that's what this is trying to tell you. So let's just delete the GitHub stuff because we are not going to use it. Next, for any port that creates shared libraries, there is a variable called shared libs, which is helpful. We'll see wantlib a little bit farther down. This actually kind of creates the wantlib for different packages. We're not going to create anything that has shared libraries at the moment. Actually, the port tree is nice enough that if a piece of software makes a shared library, it'll tell you, and you can actually just copy and paste the port's build output directly into the make file. But since we are only going to create nice little programs and we're not going to create libraries, we're going to go ahead and delete this. Now, categories. The category used in the directory name. So for us, that was math. It must be included and listed first. So let's put math in. Now we can also add more categories if we want. It's not necessary, but if we want to, we can. And so BC is a utility. It's a system theory. So let's also just add sysutils. Now we have we have written 3 whole variables. This is the point where I want to talk about port makefile formatting. Because what a lot of people will do is they will simply, and I'm guilty of this, because at this point, I kind of have my own systems, and hopefully I kind of know what I'm doing. So for me, I don't actually start with this template file. I actually will just grab a makefile from another port of mine that I think will kind of be sort of similar or kind of sort of related to whatever I'm currently porting, and just swap things out as I need. So my stuff is kind of already formatted in the style that I'm used to. But let's talk about style a little bit. Let me just scroll up to the top here, just so we can all see. We want to copy this makefile.template style-wise as closely as we can. So for us, that means variable, which will always be in uppercase, followed by a space, followed by an equal sign, followed by some number of tabs. So we always want it to be variable, space, equal sign, tab. At least one. But we also kind of want to arrange these variables in a way that's both easy to read and kind of keeps relevant or similar information together. So I like to think of these more as paragraphs than anything else. And the way I think about it is paragraphs maintain the number of tabs after the equal sign so that they all match, or at least as best you can. Different paragraphs might have different numbers of tabs, but at least within each paragraph, you'll have the same number of tabs. And for me, paragraphs are just separated by at least one blank line. That's the way I think about it. And so for most ports, and the way I think about ports, is all the information we've done up until this point is our opening paragraph. So our comment, our dist name, our package name, we have one, and the categories is that opening paragraph. So let's actually make it an opening paragraph. Let's get rid of all of these comments and put everything together. Let's leave package name again for now because we might come back to it. So this would be a paragraph. The way I think of the tabs that come after the equal sign is the minimum number of tabs needed to make the alignment happen. In this case, you only need one tab. So each one of these will get one tab, and they all nicely align with each other. That's the way I think about kind of just formatting and keeping information together in a way that's easily readable, easily understandable, and actually will save you time in the long run when it comes to updating if you have things formatted in a way that's consistent. So above everything else, consistency is most important. And I found this style is really helpful to me because it keeps things as best as possible, every variable on one line. It's not necessarily perfect, but it's as good as I found that I can get. So the second paragraph, let's think of, is the home page and the maintainer line. So let's start with home page because that's what's next. So home page is some URL that is hopefully the home page of whatever software that we have. So let's go back to GNU BC. The home page is up here at top, gnu.org/software/BC. So let's just copy and paste that in. If a home page has HTTPS, you should prefer the HTTPS. We are trying to get rid of all the home pages that are not HTTPS as best we can. Not everybody uses it, but everyone that does, you should prefer it for the home page. So next is the maintainer, the person who is responsible for the port. Use a complete email address with your name, followed by your email address in those angled brackets. For one port, it doesn't matter so much. Once you maintain more than one port, it's fairly important, I think at least, that you keep the same name and the same email address. The reason for that is here called portroad, portroads.openbsd.org, which will actually go by maintainer. So let's pick me, for instance, and spit you out a list of all of your ports that are out of date, or at least the ones that it can figure out, or at least thinks is out of date. It's not perfect, but once you start maintaining a lot of ports, it's much easier to at least get this output and at least have a place to start than it is to have to manually go and look at every single port that you maintain, go to their website, see if there's an update, figure out what to do. It's much easier, even though this is not perfect, it is super useful. So once you begin maintaining more than one port, make sure that this maintainer line all stays the same. Because otherwise you'll have multiple entries and things get harder to keep track of. So it's helpful for you if nothing else. If you don't have a maintainer line, it will default to the ports mailing list, effectively, aka ports@openbsd.org. If you are submitting a port, you should take on the responsibility to be maintainer for the port. It doesn't mean you can't drop later, because of course you can. But normally if I see a port that's new that does not have a maintainer, I will write back, did you leave this out? Because sometimes people honestly just do forget to leave out that line. But I also just like the idea of if you're going to make a port, you're going to maintain the port, at least at the beginning. Because things will fall through the cracks otherwise. If we just get a whole bunch of new ports that have no maintainer, it's very likely that those ports go out of date really quickly, and we are trying to avoid that. So this will be different for you than it is for me. But for me, I would write my name, open angle bracket, my email address, close angle bracket. And then homepage and maintainer, I like to think of as the second paragraph of a. So let's just tidy this up and put them together as the second paragraph. So for most ports that use kind of this, what I would call the common scheme of porting, you have a comment, a disk name, an optional package name, category name, a blank line, a home page, a maintainer, and then there's going to be another blank line. That to me is the most common opening for a new port. And generally speaking, unless you're using GitHub, this is what it's going to look like. If you're using the GitHub stuff will actually go in between these two paragraphs. It's kind of its own paragraph. But we're not going to worry about that for today. That will come in a future workshop. So licensing. Licensing is really important, even though it boils down to just simply a single comment, because it determines whether or not we can actually put that package in the package repository so people can type package add whatever. Not every port has a package. There are some things that we cannot distribute. FS2 Open, which is one of the games in the games category, is one I can think of off the top of my head. That it's a port, you can CD into user ports, games, FS2 Open, and compile it, but we can't actually offer a package of it because it has this very strange proprietary license. So just keep that in mind. For the vast majority of stuff, especially if you're sticking to just open source stuff, it'll all be distributable, but that's just something to keep in mind. So let's actually take a look at, let's go back to our code that we extracted from the BC tarball and see if we can actually find a license. So licenses are either going to be copying or license for the most part. And we have a copying file here. So let's actually open up copying and see what we get. Unsurprisingly, because it's a GNU piece of software, we have the GPL. Specifically here we have version 3. If you discover that the piece of software is under a GPL license, any kind of GPL license, you are not done here at simply looking at the license. If it's an MIT license or a BSD license or some other copy-free license, at this point you'd be done. You'd say, okay, great, this is a BSD license, I'm done. For the GPL stuff, we actually have to figure out whether or not it's GPL version 3 in this case only, or if it's GPL v3 or later. A really easy way to do that is to simply look for the phrase "at your option," which is the way that they introduce the "or later" clause. So there's a piece of software in the port tree that goes by AG, which I love because it's a nice colorized, faster grep essentially. If you want to download it, it's package add the silver searcher. I kind of use this exclusively as my grep, because you'll see in a second. So if you package add that, the binary you get is AG. So actually, let's look for the phrase "at your option" and see what we get. Well, it looks like to me in what I'm going to assume is every C file. Let's find out. Yeah, pretty much every C file we have this phrase, either version 3 or "at your option." Let's open up this dc/string.c. And if we do "at your option," here we go. This program is free software. You can redistribute it, blah, blah, blah. Either version 3 or "at your option," any later version. So that tells us we have a final license of GPL v3 or later. The way we would annotate that is a comment, because a license is always going to be a comment. GPL v3, and then a plus sign, which means "or later." Now, if we couldn't find that phrase, we would write the word "only." But in this case, because we have that "or later" clause, we'll put a plus sign. All right, let's then just delete all these, except for this last line here. If all the permit variables are yes, you just have to set permit package CD-ROM. Again, this is partly historical from when we used to ship CDs, but that's what we still use today. So we have 3 options here. We have permit package CD-ROM, permit package FTP, permit disk files FTP. If the thing you have is open source, you're just going to set permit package CD-ROM equals yes and be done with it. If for some reason we can't ship it on a CD-ROM, a common reason for permit package CD-ROM being no that I can think of off the top of my head is if a piece of software forbids selling. So just as an example, if let's say for some reason GNU BC forbid selling, instead of just writing no, you would actually just write selling forbidden or something like that. Actually write the reason out if the reason is going to be no. For the vast majority of people, they will never set this to anything but yes. And once something is set to yes, everything below it is inferred. So we can simply delete these two lines. Next we get to this thing called wantlib. And for now, we're going to ignore it. We're actually going to come back after we've built the software and let the ports tree itself actually write out the wantlib for us. Currently, because pledge is so new, I assume we'll probably do something similar with unveil now that that's in tree. If the piece of software that you have actually uses pledge, actually has to call to a pledge function, we are just going to put a comment that says uses pledge above the wantlib. For GNU BC, I'm sure there is no pledge call. Partly as well, especially for smaller C-based utilities, if you can pledge it, it's probably in everyone's best interest that you do pledge it and then upstream those changes, and then you can add uses pledge above the wantlib. But for now, we're going to ignore the pledge stuff because I know that this one almost certainly doesn't use pledge, and we're just going to leave these two lines. Because like I said, we're not going to touch the wantlib until we're done actually building the software, and then we're going to let the ports tree actually do this part for us, which is very nice. So permit packages CD-ROM with the comment is its own paragraph. Wantlib is a special paragraph because we're literally just going to copy and paste. And then master sites is its own separate paragraph as well. So master sites is where the source files and patches can be fetched. Essentially the entire website up until the name of the tarball. So let's go back and see what we have. So if we look up here, we have ftp.gnu.org/gnu/bc. So let's type that in. Now a master site will always end with the /. The reason being is because to actually create the URL that we're going to fetch, what the ports tree does is it concatenates master sites with distname with this other variable that we don't have at the moment called extract suffix. You would use extract suffix in the event that your tarball does not end in .tar.gz. In this case, it does end in .tar.gz, so we do not need the extract suffix variable. But just to take in, just to do this as an example, let's say it did. Let's say for some reason BC also had a bzip2 tarball. You would do, it's in the wrong place. I normally put this underneath package name and dist name. In the template file, I believe it is below master sites. Yes, it's below master sites. So you'll see stylistically, there are some places where you're allowed some freedom, or at least there are different ways of doing it that certain people prefer over others. I tend to prefer to put extract suffix right here underneath the package name because it lets me very quickly see what the full name of the tarball is going to be. Where if it's below master sites, it's a little bit more difficult to at a glance see exactly what the name of the tarball is going to be. So let's say in this case there's a tar.bz2 suffix. There's not in this case, but again, just to practice. If you have extract suffix set, it will automatically add the tools that you need to extract the tarball. So just by writing .tar.bz2 as the extract suffix, that automatically instructs the ports tree that if I don't already have the bzip2 utilities, to go get them. So we don't actually have to keep track of what we need to extract the tarball with. The ports tree takes care of that for us. But in this case, there is no extract suffix, so let's get rid of that. Now you'll see here that there are these variables with master site SourceForge and master site foo. There are some mirror sites that have their own variable for the master site name, and that's because they're like it's a round robin thing where you connect to, like here, you connect to a site and then it forwards you to the actual site that you download things from. If you are interested in seeing that list, it's in user ports infrastructure DB, and it's in, I'm in the wrong place, sorry. Here we go. Sorry about that. It's in infrastructure's templates, and then it's in this file network.conf.template. And there's just a list of all the different master site variables. In this case, we see there actually is one for the GNU sites, and you can see what it does is just give us the full list of sites. The ones you are most likely to see this on are either GNU software or SourceForge. Other than that, you actually should just write out the entire master site. So for the most part, for most ports, you actually will write out a URL. But because this one happens to be a GNU site and we happen to have a nice variable for the GNU sites, let's use that. Which would be master site GNU. If you're using a master site variable, it's always the name of the site, in this case GNU, colon equals, and then just the last part here. So just BC. And again, master sites always end in a slash, so you put the slash. So for most, and I mean most times, you'll use something that looks like this. If you happen to be porting something that's from a GNU site or SourceForge site, you'll use this. And master sites, I like to think of them as well, like I said, as their own paragraph. So at this point, we have enough of a port infrastructure to actually fetch the port. So I think we should do that. So let's save it. Now we have nothing in here but our makefile. The way to actually grab a tarball is to type make fetch. Look, checksum file does not exist. Now, that's on purpose. For all ports, there should be another file called distname, or distinfo, which actually has the name of the port and its checksum. The way to get the checksum is to do makesum. And in the process, because it actually needs the tarball to figure out what the checksum is, it'll go fetch it for you. And if we look, we now have a distinfo file. And if we look at it, there we go. The checksum and the size. So once you're at this point, you would type makesum, and that would fetch the tarball for you, and it will generate the distinfo for you. So believe it or not, we are already basically halfway home, halfway to a port. Of course, the easy half. So let's reopen our make file and keep going. The master site 0 stuff, if you happen to have a port that requires more than one tarball in more than one place, this is how you would do it. For the vast majority of things, that doesn't happen. So let's get rid of all of this stuff. Patch files is kind of the same thing. If you have patch files that exist separately from the tarball, this is how you go fetch them. The only one I can think of offhand that does that, I think, is Vim. I can't think of anything else off the top of my head that uses it. So let's get rid of it. Now, dependencies. This is where you tell the ports tree how to go, or what things you need to successfully build the software. So there are 5 different dependency lists. There's actually a 6th one. There's also a compiler. I think I'm using an older version of the template, but that's okay. Compiler we won't actually use for today, but if you did use compiler, you would use it because there's a possibility that the default compiler on every architecture, not just AMD 64. So you have to think to yourself, would this piece of software build with GCC 4.2.1? The answer is yes, then you don't need a compiler line. If the answer is no, you do need a compiler line. And the compiler line comes at the top of the dependency chain. Usually, the most common compiler line is base clang port GCC. What this says is the compiler I need to use to build this software is, if I have clang and base, use that. If I don't have clang and base, use GCC from ports, which is at the moment GCC 4.9.4. If for some reason you have to have a compiler line, you have to have a comment above it that says why. The most common reason why is C++11, and you can just write that and that's fine. But for today, we're not going to need a compiler line. But seeing as C++11 software is pretty common, that's how you would do that. So modules. Modules are a special case. They do more than one thing, and they can do extra setup for you to build the software. The 2 most common modules you'll come across are Python and CMake. So if you are building a Python module to port it, to make a package of it, you would use the Python module. And just by using the Python module, the port tree would set itself up to do all the things it needs to do to build the Python module. And so that you don't have to do it manually. CMake is the same thing. That's the other common one. If you use the CMake module, it will rearrange, or it will automatically set the ports tree to do all the right things to use CMake, like building with Ninja, like using CMake as the configure program, so on and so forth. We are not going to use any modules for today, but if you're interested in looking up the modules, there's a man page for it. It's port modules in section 5. And there you can actually see all the different modules and what they all do. So we're going to get rid of the modules line. Build depends. Build depends is software that you have to build the program that does not link to any executable or library, and then you can delete before actually running the program. It tends to be like other make software. Gmake being an exception, Gmake has actually its own variable, but things like that. Something that you need to build the software, but not to run it, and it doesn't actually link to any executable or library. I can't imagine there's going to be one for BC, but let's leave it commented out for now. Then there's run depends. Actually, I think for most ports, we tend to see it this way: build depends, lib depends, run depends, and then test depends. So lib depends. Lib depends are things that get linked into the executables or the other libraries. So these tend to be other libraries. I don't imagine that there's going to be any for BC either. Again, I picked a very basic example. But let's just say for some reason there is. Let's say for some reason it's a graphical program and it links GTK3. It probably doesn't, but let's just do it for the sake of exercise. The way you list dependencies is category followed by port name, which might be different than the package name. It's usually not, but it could be. So for GTK3, it's X11 because that's the category it happens to live in, / GTK plus 3 because that's the port name. And so what this would do would be, before we actually can even build BC, the ports tree would say, do I have the GTK3 package installed? If I do, great, I can move forward. If I don't, let me go build and install that for you first so that you have it, because otherwise you can't actually build the software. And the same is true for build depends. So if anything is in build depends or lib depends, it will go and fetch and build and install those things first. And then it will come back to the port. The ports tree is nice in that it can recursively call itself. So if you have libraries that depend on other libraries and so on and so forth, the ports tree can actually fan out and go do everything and then come back and then build the actual port that you want. If you have more than one build depend, lib depend, run depend, you sort them in alphabetical order by category, one per line. So let's say, I don't know, what other libraries do we have? Let's say for some reason it's also an audio library, or it needs an audio library. Let's say it needs OpenAL, which happens to live under audio, OpenAL. So we'd sort them by category in alphabetical order, so audio comes before X11. Of course, if they were in the same category, then GTK3 comes before OpenAL. But we have two on the line now, which we don't want. So the way to do it is to put a space after, and then a backslash. And then on a new line, tab it out so that they all align with each other. And this is why, for me, keeping things tab aligned within paragraphs is so important. Because just stylistically, it just helps you kind of focus and see the information that you need to see to get things done. And then let's say for some reason it needed, I don't know, let's say devel something else. I can't think of anything else on the top of my head. So you just go through. It's a space followed by a backslash and then tab align. The last one, of course, just ends at the end. There's no space and no backslash for the last item. But again, I doubt that there's going to be any lib depends, but let's just keep it around for now just in case. Next is run depends. A run depend is a piece of software that you don't need to have around to build, does not link into any of the libraries or any of the executables, but the software won't actually run unless it's present. Let's say for some reason BC did something like it was only able to be, it opened Nano, and then you actually used Nano to interface with BC. You wouldn't need Nano around to build it. You wouldn't need Nano around to link into anything because it's not going to link any libraries, but you would need it to actually run the program. So in that case, you would do this. But again, I don't think there's going to be any, but let's just leave it here. So to recap, build depends are things you need to build the software, but not run it, and does not link into any executable or library. Lib depends is something that links into an executable or library. Run depends is something that you don't need to build it with. It does not link itself into any of the executables, but the software won't actually run unless this is also present. And then there are test depends, which is you don't need to build, doesn't link in, don't need to run, but there's a test suite that requires this program or library. That's what you do for test depends. Then we have these extra lines here. For my preferences with formatting, this block of 4 actually goes lower. So let's actually do that. Let's actually just take these lines and move them down and just come with me. So let's just yank these. And I prefer to keep these in with where the other build tools are, which is actually pretty far down. It's actually right here underneath the configure stuff. So let's paste those here for now. And we'll come back to them when we get down here. So build configuration variables. Separate build. CMake actually sets this one for you automatically. So if you use the CMake module, you get separate build for free. Separate build is to put all the object files and all the executables and libraries in a folder that's separate from the folder, separate from the directory that the source lives in. This is one that you should only turn on after you've already successfully built the software at least once. Because in my experience, there are a lot of kind of stray errors that come from ports that you actually cannot separate build, but people turn it on a little too early. So let's leave separate build in, but let's leave it commented out for now, and we can come revisit it later. This flavored one we'll save for a more advanced workshop because we're not going to deal with flavors today. So let's delete that. Now we have also use gmake, use groff, use libtool. These three are kind of together. I would personally put these three below the configure stuff. And in fact, let's go ahead and do that. Let's put those below the configure stuff, and we'll come back to it when we get down there. So I would put the stuff right above all that make flag stuff that we just moved. So let's delete these. Okay, now we're actually ready to go look at the software that we have and figure out how to build it. So the order for most things to build is configure, then make, then install. Not everything has a configure script. Some things just have a make file, which is super easy. If it's just a make file and there's no configure step, you can just delete all the configure variables because you don't need them. In this case, we do need them, so we'll keep them. But we have to figure out what we have. So set configure style to value corresponding to some standard configuration. Perl, which I'm pretty sure the Perl module gives you, but I could be mistaken. It's been a while since I've actually had to make any Perl modules or Perl packages. GNU is the one you will see most often. iMake you'll almost never see anymore because I don't know if anybody is using iMake for new software. And then Simple, which you will see on occasion. So the ones we're going to focus on, I'm going to delete the ones, are GNU, and simple. There's also autoconf, which you would set if you only have the configure.ac, but unfortunately it doesn't always work because autoconf is tricky software. So we're going to get rid of autoconf too. So we just have GNU and simple. How do we figure out which is which? The easiest way to figure out which is which is to actually open up the configure file and see what we get. So we open up the configure script. If at the very top you see something like generated by GNU autoconf and then some version number, you have a GNU configure script. If you don't, you probably, well, almost certainly have a simple configure script. And it's really that simple. So in this case, we see generated by GNU autoconf. So we can set configure style to GNU. We're done. If for some reason the script name is named something other than configure, you have to put that in here. That's almost never going to happen because configure is a pretty standard thing these days. So you'll almost certainly delete configure script. Configure args is if you have arguments that need to be passed to the configure script, you'd put them in here. Now the same rules would apply to configure args and pretty much everything we do from here on down as with the dependencies. Alphabetical sort, 1 per line, space, backslash if you have more than one. Configure environment is if you need to pass some environmental variable to configure. Most often you're using configure args. Configure en environment is less common, but let's just leave them both in here for now. Let's delete these comments. I like to think of each step as its own paragraph from this point forward. So the configure stuff will be its own paragraph. The make stuff will be its own paragraph. And then we won't see it today, but there's a fake paragraph and a test paragraph. So I like to think of them as the 4 paragraphs that you need to actually do the building steps. Configure, make, fake, which is actually install, and test. Because gmake is such a common build dependency, if you need to use gmake, you actually don't have to bother putting it into the build depends. You would simply use this use gmake variable and set it to yes. If it is no, and this is pretty much standard, then you simply don't have the variable at all. I don't know if we're going to need gmake or not, so let's leave it in for now. But let's leave it in as commented, so that we can easily uncomment it if we need to. Now, you'll notice that the tabbing for gmake is not aligned with the tagging for the configure stuff. And that's okay, because they're separate paragraphs. Then there's use groff. Only a small handful of ports still use groff. I mean, Ingo has done an amazing job with mandoc and the ports tree and getting basically everything to use mandoc these days. And he should be applauded for that work, because it's just a ton of work. That often doesn't get a lot of thank yous, so go thank Ingo next time you see him. Because of that, only in super rare events will you ever turn on use groff. At this point in time, you can basically just delete it as a matter of practice. If a program needs specifically GNU libtool, which is different than the libtool we actually have in base, you would set use libtool to GNU. That's really only going to matter in ports that use shared libraries, and for the most part, our libtool is fine. You'll almost never need the use libtool. So let's just delete that whole block and come down to make flags. Now, I'm just going to write these out down here. There are variables like C flags, CXX flags for C++, things like LD flags for your linker. There's also CC and CXX for your C compiler and your C++ compiler. These are the 5 most common make flags that you will set. If you set one of them within make flags, it totally overrides whatever else is in that port. So you would use this, let's say for example, a port for some reason hard codes GCC as the compiler. But some platforms like ARM64 don't even have, because they only use Clang. You can actually use something like make flags CC equals. Now I realize that looks somewhat tautological to say that CC equals CC, but what this is actually doing is it's overriding the CC variable in the make file that comes with your port and replacing whatever option it happens to have for CC with whatever option the port tree believes is CC, which in this case would be user bin CC, which is generally what we want. We want to avoid hard coding things as much as possible. If there's an opportunity to use a variable, you should use it, is the general rule, I guess you can say. And if for some reason we would need to overwrite our C flags, we can do the same thing. So each one of these 5 have a default value already set. For C flags, it's O2 pipe. Same thing for CXX flags. For LD flags, I believe it's blank. For CC, it's system C compiler. For CXX, it's system C++ compiler. And you can set them just like that. And again, they're overwriting what is in the makefile that comes with the software, with whatever the port tree believes it to be. So even though it looks like you're just kind of assigning it to itself, you're actually not. So just keep that in mind. The general style for, as you can see, I put the variables in quotes. That is the general style for these. Because, right, you can do something like that, which would replace C flags with whatever comes from default from the port tree, which again, by default is O2 and pipe, and also adds the format warnings. I don't think we're going to need anything in make flags, so I'm just going to comment it out for now. Make environment is the same thing, except for environmental variables. This is commonly done with gmake to have verbose output. Common in gmake to do something like that, which turns on the verbose switch for a lot of gmake stuff. Now for fake flags and test flags, I would actually make them their own separate paragraphs. Really just for organizational purposes. So, right, everything in the configure step is its own paragraph, everything in the make step is its own paragraph, everything in the install step is its own paragraph, everything in the test step is its own paragraph. And that just helps you visualize and see what's going on. Or at least it helps me. We're not going to use any autocomp stuff today, but if you needed to use autocomp for anything, this is where you would set things. But we're going to delete them for today. Is the build automagic or is it interactive? I can't think of any port at this point that is an interactive build. So this one is almost certainly just delete automatically. This one is really close to delete automatically. I think there's like 1 or 2 ports that I can think of that have interactive tests. But you're generally safe to just delete those. All of this stuff down, let me just check real quick. Yeah. So all this stuff here about flavors for today, because we're just doing the basics, we're just going to get rid of them. We'll come back to them in kind of like a more advanced porting workshop. But for now, let's just get rid of them. Because they'll sow more confusion than questions that they'll answer. So sometimes you actually don't need a port to build anything or test anything. Generally, if a port doesn't need to build anything, it's because it's something like a shell script that you're just installing. Screen fetches like that. So the little program that's used to get like a nice little output to take screenshots with, actually it's just a bash script. So you don't actually build anything. If that's the case, you'd set no build to yes. It's the same thing like everything else. If some of these are no, you don't actually set them to no, you just don't have the variable. So we're going to build something because we saw we had C files, so this one can go. Not every port comes with tests. There's really no way to know whether or not the port has tests or not until after you built it. So let's leave no test commented out for now. Next is overrides for default values. The C flags and the LD flags, my preference and the way you tend to see them is that they go up into the make flags. That's not universal. Sometimes there are reasons to actually override them directly, but I would at least at first try putting them in make flags before having to override them in the port make file itself. So let's get rid of the C flags and the LD flags for now. Makefile, so the ports tree looks for a makefile called makefile with a capital M. If it's something else, that is what you would set makefile to. Common things are lowercase m makefile, sometimes you see. Sometimes you also see GNU makefile. Those are the ones you tend to see most often if you have to override the makefile. Most, if not all the time, that you have a configure script, especially a GNU configure script, it's going to make a capital M makefile, and you're not going to have to worry about that. So for today, we can get rid of this makefile. Package art, you basically never set. The exceptions are, it tends to go hand in hand with no build, especially if it's just a shell script. Because it doesn't matter what architecture you have, it's a shell script, it'll run anywhere. In that case, you'd set package arch to just star, which again, as it says here, it means it's arch independent. Again, if it's a shell script, it's going to run anywhere. But we are going to compile something today, so we can get rid of this. Now we have these interesting things here: work dist, work source, work build, work conf, work dir. The short answer to this is, we save this real quick. If you're ever wondering where things are, there's a really handy make show equals. And then you can write any variable you want, and it will spit out the answers. So if you make show, let's say dist name, just to demonstrate, we get the dist name. So what is work dir? Because work dir is the one we start with. Work dir is user ports pobject bc-1.07.1. Essentially, work dir is the location where everything will be built and installed, both of those things, and configured as well. The next one is work dist, which, as you can tell, actually goes one layer deeper. So now it's pobject bc/bc. The way I like to think of work dist is this is the location relative to where patches are generated from. It's not entirely what work dist is for, but that's the best way I found to think about it. So if you have to make patches for a piece of software, this is the directory relative to where those patches are made. And then there's also work source, which in this case happens to be the same as work dist. It doesn't have to be. but more often than not, it will be. Work source is best thought of, at least for me, as the directory relative to where your makefile lives. In most cases. In this case, it would actually be relative to where the configure script is. You almost never need to set these, but in case you do, you can simply set them directly in the port makefile. And so as you can see, work dist defaults to work dir/dist name, work source defaults to work dist, work build will change if you turn separate build on, but it will do so automatically. So you won't actually have to set this if you set separate build. It will be set for you. And then work conf is the same if different than work build. I can't think of any port that actually uses work conf. So this one almost always goes. For us, actually, all these are going to go because we don't actually need any of them. All target. By default, the ports tree searches for a makefile called makefile, capital M, and inside that makefile, it looks for a target called all. Again, if you're using the GNU configure stuff, and a lot of stuff does, that's all set for you, and you won't have to worry about it. But if for some reason you have a makefile, a common thing to, not super common, but a thing that I see more often than I expect to, is instead of having an all target, the target that actually builds the software has the name of the software. In that case, it would be something like all target BC. But in this case, it's going to be correct. We don't have to worry about it. These other two, you're never going to use. At least I've never found use to them. It would be the same thing. For install target, during the install stage, it looks for a target called install. If for some reason it is named differently, you set it there. And test target you could use sometimes. Again, it's looking for a particular target, check or test. If it's neither of those, put it in there. But we're going to get rid of it. And then we have this last line, .include bsd.port.make. You leave that alone. That's just always going to be the last line of your makefile. So let's go back to the top and see what we have. So we've pared this down to a 48-line makefile, more or less. So let's just tidy it up a little bit. Or let's look it over one last time to see if we need to tidy it up. So we have our comment, our dist name. We might have a package name, we don't know yet. Categories as our opening paragraph. We have a home page and a maintainer as our second paragraph. We have the license, and yes, we can distribute a package as our third paragraph. We have a want lib that we don't know about yet, because we won't know this one until after we've built the software. We have a master site paragraph. For these dependency paragraphs, I actually like to make each one its own separate paragraph. Again, that's just helpful for me to see things, and tends to be the style that you'll see in a lot of different ports if you peruse the ports tree. So I like to make them separate paragraphs. Again, it's more my style and the way that I'm used to building ports, but I think it's a good kind of like neutral formatting style. We don't know if we're going to have any of these yet. If we don't have any, we'll delete them, but let's just leave them in for now. Configure style, we know we have a GNU configure script because we went and saw it, and it said GNU autoconf. We don't know if we have any arguments yet. We don't know if we need any environment variables yet. We don't know if we need gmake. It may be the case that our own in-base make, BSD make is fine. It'll probably be fine for today. But if we need it, we have them there ready to go. Let's get rid of fake flags and test flags, because we're not going to need them for today. That I'm pretty sure of. And we don't know yet if GNU BC has any tests. Again, we'll find that out after we actually build it. So let's leave no test commented out for now. And that, believe it or not, is more or less a completed makefile. once we build the software, we'll have a better handle on what we need to uncomment or delete. But for all intents and purposes, this is how you build software, or at least how you build packages on OpenBSD. So let's save this so we have it. Let's actually go back to the BC source code. So we know we have a configure script. The nice thing about GNU configure scripts is you can get the options that it will take by actually just running it with the help flag. Because it's GNU, it's the double dash long flags. So let's just run it. Let's just run configure help and see what options this thing takes. Scroll up a little bit. So it tends to be, so you'll see here, there's actually a lot of different kinds of flags. For the most part, this fine-tuning thing, the ports tree takes care of. If for some reason it gets something wrong, or for some reason something's like super hard-coded into a make file, you can override it with any of these. Mander tends to be the one that gets changed, because a lot of the GNU stuff assumes user local share man, whereas the ports tree is user local man. Program names, I think it's probably a good idea that we set one of these. And the reason that I'm thinking that is because we already have a program in base called BC and DC, right? There's a, if I type BC, I get something. Same thing with DC. Because we already have these programs in base, because my assumption is a GNU software called BC is probably going to generate an executable also called BC. I'm thinking that it would be in our best interest to actually rename this one. If you search through the ports tree for other GNU software, we actually do it for all the GNU software, and we always prefix them with the letter G for GNU, right? Gmake, there's also GED for the ED editor, GTAR, so on and so forth. For most programs, you will not have to change the name. The name that it comes with is good. But because GNU, and because we know that this is going to create executables that we already have of the same name, let's go ahead and change it. And also, it's just good practice for us to set some flags. So I think I like this one, program prefix. Append prefix to installed program names. Okay, let's open up our makefile again. Now, this would be an argument to the configure script. So, let's go down to our configure paragraph. And we have configure args. Perfect. This is where it would go. So now that we know that we have at least one configure argument, let's uncomment it. And then let's tab out so everything is aligned. And let's paste it. So program prefix, G is the one that's most common. So let's do G. And now, when we actually run configure from the ports tree, it will pass that flag automatically to the configure script. Let's see if there are some other flags that we might want to use. So the optional stuff, some of these optional features are actually already set in the ports tree. And so we don't have to worry about them. And in fact, I don't think I've ever set any of these here in optional features. Again, because some of them are actually already set by the ports tree. And let's look at optional packages, because this is where the software-specific flags tend to live in this optional package. It's always the last block. So we have with package, without package, with libedit. Well, that's interesting. So we actually have libedit and libreadline, for that matter, in base. And my assumption is libedit will, as it says, support fancy BSD command input editing. It'll let us use the backspace key. It's probably the most important part of that. So I think it's a good idea for us to use libedit, because we might as well, because it's already in base. So every architecture of OpenBSD has libedit. So let's put it in. So let's highlight it, or other ways to copy. So we already have one configure argument, program prefix. We want to add with libedit. So we want to sort them alphabetically, so they'll come below. So after program prefix, let's put a space, a backslash, new line, tab until everything aligns, and then we can paste with libedit in. And because libedit is going to be the last item, because there is no other flags that we could look at after this, we do not put a space, and we do not put a backslash after with libedit, because it's the last one. And I don't think I saw anything configure environment that we need to worry about. Probably not. So let's get rid of configure environment, because we don't need it after all. So now our configure paragraph is, to our best guess, finished. Now we might need to go tweak it later, but for now, let's actually try to configure it and see what happens. So let's save the make file. To configure, or to run configure for a port, you would type make configure. And doing so will run configure for us. Now, one thing that you can do, especially for really long outputs, and something that might just be a good habit to get into sooner rather than later, is to add at the end of all these commands to redirect standard error to standard out, and to pipe all that into a log file, something like that. And that way, for whatever reason, if you close the window, if your machine crashes or whatever, you have log output. That could be a good habit to get into. For now, let's actually scroll back up and see exactly what configure told us. And what we're looking for here are to make sure that the name of the compiler is correct, which it is, it's CC. And anything else that might kind of catch our attention. And usually things that would catch my attention are if for some reason a header comes up no that we have, or a library says that it's missing even though I know it's installed. Those are the kinds of things that I would pay attention to, or would be more likely to pay attention to. So this actually I would pay attention to this line, checking for bison. It's probably just checking for any old YAC program, and indeed it just finds our in-base YAC. Let's see if I actually have bison installed, because I don't know if I do. I do have bison installed. So that's good. That means that it is not preferring the GNU tools to the system tools. If in fact bison showed up here instead of YAC, we could use the environment variable YAC in our configure environment variable to force it to use YAC. But we're not going to have to for now. And looking through, all this looks what I would expect. Here we go. So it does in fact find libedit, which is great because we told it to. And everything here about libedit looks correct because it found libedit, it found libtermcap, which will need to be linked into libedit. It found the header files that it needs, and they work, and using the libedit library. So good. So we don't have to worry about playing with anything for that. If any of these were to show up as no, and that is way more likely to happen with libraries that are in ports than libraries that are in base. This is where you would play with, in the make flags, something like LD flags or C flags, or even CPP flags, which I think we'll save for the next iteration of this workshop. At the end, everything seems to be normal. This last line, warning, unrecognized options, disable GTK-doc, you can safely ignore. Like I said, the port tree already does set a couple of configuration arguments, and that's one of them. And it just so happens that there isn't actually a disable GTK-doc flag, but it's harmless if you have flags that it doesn't recognize. Okay, so everything configured properly. So I guess the next thing to do is to actually build the thing and see if it builds. And the way to send off the build is to just type make build. And then we will sit back and hopefully we'll get to the end. So that was fast, and it's done. And because we just got returned back to our command prompt, there were no errors. But let's go back and actually look at what was going on. One really important thing for ports is to make sure that it is verbosely outputting everything that it's doing. There are some make files and things that try to hide all this from the user and give you like a nice pretty output. You'll have to go and remove those. Because we actually want to see what's going on, because we want to be able to double check. So let's see what's going on. We have our C compiler, a bunch of flags. All these include flags, and the define flags we can ignore for the most part. It's here that we start to care about things. So these are our optimization flags. So these flags actually came from the ports tree itself. It didn't actually come from BC, which is what we want. So O2 and pipe are our default C flags. There are obviously more added, as we can see. But what we really want to avoid here is we want to avoid hard-coded optimization flags. So if you see something like O3, OFast, OS, O0, anything other than O2, it means that there are other optimization flags being passed in from the port itself. And we actually want to get rid of those. We want to build everything with the port default C flags because we want to give users the option of changing them and actually that making a difference in their builds. And the only way to ensure that is to get rid of any hard-coded optimization flags. So if you see things like O3, O0, anything that's other than O2, it means you'll probably have to edit the make file and just get rid of those. And we'll go over at the end of this how to make a patch. So you could do that. And it looks like everything compiled and everything is normal. So great, everything built. So we can go back to our port make file. And because everything built okay, we know that we don't actually need any of this make paragraph because everything worked just fine. So we can just get rid of that entire make paragraph, which essentially says just use the in-base make and nothing special needs to be done. So now we are pretty close to being done with this thing. We also know that there are no build depends and there are no lib depends. Because at this point, the build would have failed if there were things that were missing. Either the thing would have refused to build because we were missing things that it needs to build, or it would have refused to link because we were missing libraries that it needs. So we already know we can get rid of the build depends and the lib depends. In this case, we can also get rid of the run depends. If you wanted to be very exacting, you can go scour through both the source code and the build output a little with a more fine-tooth comb, I guess. But there are also going to be no run depends here, so we can get rid of that as well. Now, if you're wondering why I got rid of lib depends, even though we linked with libedit, it's because lib depends are only for things that are also in ports. things that are in base, you get for free, which also means everything from X11 you get for free, because that's part of Xenocar, which you get in OpenBSD base. So if a library is in base, it's not a libdepend. Only libraries that are in the ports tree have to be listed as libdepends. So that leaves us with just whether or not we have any test dependencies. And we still don't know if we have any test depends or not. Well, let's find out. To run the tests, you would simply type make test. Hopefully there's a pattern emerging. You just type make and the thing that you want to do, and it'll do it. So for make test, if you get any output whatsoever that isn't an immediate error saying there's no such target as test or check, then you have tests. Even though here nothing actually ran, this technically means we had tests. So because we had tests, and because they built just fine without us having to add any dependencies, we know both that we have no test depends, which means, by extension, we have no out-of-base dependencies, so we can just get rid of all of that. And it also means that we do not need to set no test, because when we ran make test, it did something. So we can get rid of that whole block as well. So believe it or not, at this point, we're now down to 27 lines. And this port make file is really, really close to being done. We're just about finished. We still need to figure out what to do with this wantlib thing, though. And here, this make port lib depend check thing is exactly what we're going to run. But before we can run that, we actually have to run one more step. And that's called the fake step. Fake is for fake install. What this does is, remember when we looked at the package and we untarred the package and there was that directory hierarchy? What the make fake step does is put everything in those directories so that we can easily then tar it up afterwards. So that one is just make fake. And it's done. Now we can run make port lib depends check. Error reading plist. So it means we have one more step to do. We actually have to make the packing list. And, as you've probably guessed, it is make plist. And the port tree takes care of all that for you. So now there's actually a new directory inside our port called package. And inside that directory is a plist. So let's take a look at it. So inside our plist, we have two binaries, GBC and GDC, which, remember, got named that because we set that configure flag to prefix the binary names with the letter G, which I figured would have to be the case. And it turns out I was right. It would just have made a program called BC and a program called DC. And since we already have those two program names in base, it's good to have a different name. Also has two man pages, which got installed in the correct location. So we can see here, so remember, all these things are relative to user local. So we have user local bin GBC, user local bin GDC, user local man 1 GBC, and user local man 1 GDC. Those are the correct locations. If for some reason those manual pages were in user local share man 1, we would have to go back and probably change the configure option or add a configure option to change the manual page directory. But we don't have to here. And we also have these two info pages. The GNU project likes info pages. We should probably just leave them in because we get them for free and it would be more work to take them out than to just leave them in. And I'm assuming there's probably useful information in them. So great. Our plist is done and set and doesn't need to be tweaked or fixed up or anything. Now we can, for real this time, run make port lib depends check. Now, how do we parse this output? Missing. It tells us a list of libraries that got linked into either the executables or to the other shared objects or shared libraries. And there are no shared libraries here, so this is just the things that are linked into the executable. So the C library, which makes sense because it was written in C. The curses library, which you probably got because of libedit. And libedit itself is there. So it tells us what object it was actually linked into. And then after that, it says systemlib. So that tells us that these are libraries that exist within the base system. If there are libraries that exist outside the base system, it'll tell you that too. The real key when checking this output is that last column. You want to check to make sure that there's nothing there that says missing. If, here, instead of systemlib, it said missing, that would tell us that there is a library in the ports tree that got linked to something that we did not declare in our library depends. So we need to go fix libdepends in that case and add in whatever was missing. And the good thing is it would still tell us what the library was, so we would just have to go find that library in the ports tree. Now, remember when I said that wantlib was just a copy and paste operation? It is. If we just copy the wantlib and place it here, then we're done with it. And we can clean this up. And so we want the wantlib to be its own paragraph. Now, you may get multiple lines of wantlib. This is especially true with graphical applications. You can get 5-6 lines for some really big ones, but it's the same deal. You would just copy and paste whatever the output of make want libdepends check is. And we can double check to make sure that everything is okay by running make port libdepends check again. We do that and we get no output, then everything is okay. And we're almost done. So let's double check our makefile one last time. And let's not get rid of those quite yet. This is the meat of our makefile, and it's pretty much done. The only thing that we have left that's a question mark is this package name. And my thought process is you want to name your package name something that is going to be the same as the binary that you install. So you can just package add the name of the binary. In this case, it's GBC. It's not BC because we changed the name with this program prefix line towards the bottom. So maybe it's in our best interest to change package name to GBC. So let's do that. Let's uncomment the package line. Let's actually change it to GBC. Again, version numbers are going to be the same. So it'd be 1.07.1. Now, if you've noticed, the dist name and the package name have the same number. And that is almost universally true. And if you remember, at one point I said something like, if you have an opportunity to use a variable, use it. So in this case, this 1.07.1 is a great place to use a variable. That way we only ever have to change it once. So the next time BC gets updated, we just crank one number instead of two. It saves a little bit of time, and it makes sure that you don't accidentally forget things. Here, it might be more difficult to forget because they're right next to each other, but there are times where you'll use the same numbers in many different places in a makefile, and keeping them all together in one variable really, really helps. The standard way in my formatting scheme to do it is above the comment, make a variable titled v. And then again, equal sign. Now, here we tabbed once, and we notice that it's not going to align with everything else. So remember, to keep your paragraphs aligned. So just tab out the v until you get to everything else. And then we can just put 1.07.1. And now, we can remove the numbers here and replace them with a v variable. And now, every time we crank this number, both of these get changed. Now remember, the disk name is the name of the tarball that you are going to download. So that has to be BC, because if we look at the web page, it's BC. Then GBC for us, because we changed the executable name, is GBC. And this follows the convention of other GNU software that's in the ports tree, that we prefix them with G, and we prefix the name of the package with G. So there we go. If you wanted to be really, really fancy, you could actually make package name the letter G followed by the disk name variable, something like that, and then you can get rid of V. But let's not do that for today. Let's keep it like this. Whoop. Let's keep it like this. And believe it or not, we are done with our makefile. This is a complete makefile. Yes, it took 2 hours, but because I spoke through everything. So let's remove these extra comments. Let's not forget about this port check thing. We do this port check thing at the end. But let's remove our comments. And we're down to 23 lines. So this is it. This is a complete makefile. Everything that you need to do to fetch the software, to build the software, to install the software, to make the package is right here. So let's save this. Now we're not quite done. If we try to run make package now, which you would think would be the next step, we've installed it to the fake directory. Now we just need to tar it up. We're going to get it. Did I clean it by? Oh, it's building again because it changed the name of the. We changed the name of the package, but that's okay. It didn't take very long. So now you know if you change the name of the package, it's going to rebuild it. Now, I tried to run make package, and I got this error. Can't open user ports, my stuff, math, BC package, description. Inside the package directory, you should always have at least 2 files, a plist and a description. The description is the long form description. This is the thing that actually shows up when you type in package info. The way I like to do it, because I'm not good at eyeballing column lengths, is I start with a file just called capital D. And inside capital D, I basically write whatever and however much I need to make a full description. So let's go find a full description, actually. And I think these 2 opening paragraphs on their homepage probably do a pretty good job. In fact, we might only need this first paragraph, because I don't think anyone cares about whether or not POSIX specifies how BC must be implemented. Let's just copy and paste that first paragraph into this new capital D file. And let's be a little more precise. This is GNU BC, so let's actually start it with GNU BC. In fact, let's make every mention of BC into GNU BC. But there's also DC in this package too. If we remember, there's 2 executables. There's BC and there's DC. So let's just add another sentence that says something like, this package also includes GNU DC. That way, someone who's just kind of skimming through packages and doesn't necessarily know that BC comes with DC will get that information when they run package info. So now that we have this, let's save it. Generally speaking, although it's not a hard and fast rule, the preference, and this is certainly my preference, is to column stop descriptions at 72. And the easiest way to do that, although by no means the only or even necessarily the best way, I think, is to do format 72D into description. After that, we can get rid of our capital D because we don't need it anymore. And now, if we look at the description file, it comes out to be 72 columns. In general, you want to keep the description to be no larger than a single 80 by 24 terminal size. So, long description, but still, shorter than 24 lines is generally what is preferred here. So now we have the description file, we have a plist file, and we have our make file, our dist info. We have a completed port. So now if we run make package, it happily builds our package. This is the point where I would run port check. So to run port check, be user ports infrastructure bin port check. And if all you get back is the category and the port name, then everything is okay, at least as far as port check is concerned. Which means this port at least follows kind of all the standard conventions of port output and layout. And if we run make install, it will happily install our port. And then we can actually run gbc, and we actually get GNU BC. Cool. We went from start to finish. Let's do a couple other things, just because, well, I thought this would only be 2 hours. See, this is why it's important to test run this on all your friends, because you all won't get mad at me. I hope, I think. I'm not actually sure. You could all be super mad at me right now for all I know. But let's do one more thing. Let's make a patch. Actually, let's do 2 more things. Let's make a patch, and let's learn how to update ports, because we can knock that out real quick too. So patch making. If you need to change something in the source code to make it build on OpenBSD, which you will certainly run into very often, they'll have to make a patch. We're just going to make a trivial one just to say that we did one. It's not actually going to change anything about the output of the program. So normally what will happen is you'll be building the software and everything will be fine, and then the compiler will error out and it will give you an error. And then you have to go into the source code and fix that error. That's the most common reason for making a patch. But let's just make a patch for the sake of making a patch. So the easiest way to do that is to just enter into work source. And again, because we have that nice make show, we can encapsulate that and then just cd into it. And it brings us into the directory. So let's do... so the source code is in a BC directory. Okay. Let's just change the README, because that way we won't actually affect anything. So, first thing you want to do is to copy whatever file you're going to change into that file name .org. .org is the default that the port tree checks against when it generates patches. So that's the first thing we want to do. Now we can edit the README to our heart's content. So let's say, hello everyone, this is a patch. Okay. Or write whatever you need it to be. Then once you're done, we can save it. And then we return back to our port directory. And now we can run make update patches. When we do that, the ports tree automatically generates the patches that we need to. And it'll and if you make more than one patch, it'll just generate however many that you made. So you don't have to make them one at a time. You can make them in bulk, and it'll just generate them all in bulk. For most patches, most of the time, I like to put a comment in that just says why I made this patch, and you would put that stuff here. Comment on why this patch is necessary. And comments can be as long or short as you want them to be. My preference is to leave a blank line between the RCS ID and the comment, and then another blank line between the comment and the beginning of the actual patch. Just because it makes it easier for me to read more than anything else. When you're done, you can save it, and you'll notice there's now a new directory called patches. And inside patches is our patch. And patches come in the form patch dash, and then it's the path to the file, which is relative to work dist. Not necessarily work source, but work dist. And the patch name will always replace slashes and periods with underscores. So just keep that in mind as well. We could do a pledge patch, but it would take us all to actually read out the source code, and we're already at like 2 hours. So maybe that would be a good exercise for somebody who wants to submit this to the port strip, is to figure out what pledges it actually needs and to make that patch. And the other thing I want to touch on just really quickly is how to update a port. So if you remember when we looked at, let's go back to that nano package that we looked at the very beginning. If for any reason anything in the contents or the description changes, or anything in the package, really anything in the package changes, you need to set what's called revision if you are not already changing the version number of the port. So this can get a little bit tricky. So there are 2 other variables called revision and epic. Revision means something in the package changed, but the version number didn't go up. And for both revision and epic, you start at 0, and every time you then change it from there on, you increment it. If the version number changes, you get rid of revision entirely. So let's say we have a revision 0. When this gets changed to 1.08, revision gets deleted. And then we'll start again from 0 if there's a need to revise the package. So revision, again, means something in the package changed, but the version number did not. Epic is interesting. So epic you set in the event that the version number goes backwards. So let's say for some really strange reason, the next version of BC was version 0.5. It's not going to be. But let's say, for argument's sake, the next version of BC was 0.5. That would go backwards. In that case, you set revision, because when the package system checks to see whether or not something is newer or older, the first thing it does is check epic. If epic exists, it's newer than epic not existing, and then numbers from there on up. And again, you start at 0. Once epic is set, it can never be deleted, and it can never go backwards. So if you have a port that has epic set, and you change the version number, you do not delete epic. You would delete revision if there is one, but you would never delete epic. So, to recap, revision means something in the package changed, but the version number did not change. Epic means at some point in time, the version went backwards. And we need this to maintain the ability to update going forward. Epic is never deleted. Revision is always deleted when you increment the version number. Obviously, for this port, we don't need either, but those are two really important variables, and when to play with them and when to not play with them. So at this point, for all intents and purposes, minus the pledge patch, which hopefully someone will take up on, that is a complete port. That is to go from 0 to something ready to be submitted and committed to CVS in 2 hours. And I said it faster than I thought I would. I actually have here, if you want to try your hand at going from 0 to a completed port yourself, I have a little program here which has a tarball ready to go. And I'm obviously going to be around. And try your hand at it and see if you can get a completed port done. Obviously, I'm not going to time you because you'll move at your own pace. And I think I'm probably going to sign off soon. But yeah, hopefully this was helpful to everybody. I think the next time we do this, I will figure out a way to have us all talk to one another. Not that it's strange to talk to myself, although I guess it is kind of strange to talk to myself. But I think it would be helpful for myself and for you all to be able to talk to one another in case I'm going too fast or going too slow, something I said you didn't understand or whatnot. So I think we're going to try that next time. Try to find a way to do audio chat. And then we can actually make ports together in real time. Yeah. Does anyone have any questions? Does this make sense to everybody? Is this helpful to people? Would you want this to happen again? That's the real question. And I guess I'm going to sign off unless there's anything super pressing. Which it doesn't look like there is. But yeah. So thanks for trying this out with me. This is something new, obviously. Hopefully, it's helpful to get more people involved with ports, to kind of have this step-by-step what's going on in my head as I do things. And right, this is only to port more simple things. There's the FAQ on the OpenBSD website, the Porter's Handbook, which is the important thing. If you want to kind of dive into this more seriously, I would say check out the Porter's Handbook in the FAQ on the OpenBSD website. There's a lot more advanced things than we went over today. If this was helpful and interesting and useful, we'll do this again, and we'll kind of iterate on this. We'll do more and more advanced porting work each time. But I think 2 hours is probably the right, the right target time. It's what I had in mind, and I think it works out. So yeah, I don't see anybody in the chat room saying anything. Sorry, chat. I'm going to log off, and thank you for coming, and we'll do this again. And if you have any questions, to message me, either on Mastodon or Twitter or anywhere else you can find me. All right, thanks, everybody.